fangen an heute mit unserer Vorlesung 2020, März 31. Und zwar werden wir heute weitermachen mit ein paar grundlegende Konzepte. Das erste möchte ich eine Definition machen von Lean Management. Diese Definition kommt von Shah Anwar in 2003. Ihr könnt euch das Paper herunterladen. Steht verfügbar im Internet. Und zwar, die Typen da definieren Lean Management als ein sorry, we should do it in English. Social, technical, socio-technical management system that aims to reduce process. When I say process, you know I mean value stream, variability. Okay. So lean management is a management system that is a social technical management system that aims to systematically reduce value stream variability. Okay. So let's go step by step. This means that we have a social and a technical dimension. So we need to talk about that. Okay. We have a social technical dimension. This is number one. Social technical dimension. Then we have a management system. Management system. Management system means that we try to achieve some goals. Okay, our managers try to achieve some goals. This is the manager with his or her arrow, and she tries to achieve a certain set of goals while increasing trust. Okay, so management. I'll give you a definition of management. Means achieving goals while increasing trust. Management or leadership means achieving goals while increasing trust. And we need to talk about that too, because if I achieve my goals, but I don't increase my trust, so goals and trust. If I get to the goals and my company is incredibly successful, but I don't increase trust, I will not have these goals for a long time. Think about the automobile industry. Achieving goals, but by cheating in the AFGAS norm. Okay? Increasing, achieving goals while increasing trust. So the third thing is that we have a value stream, and we have already talked about that. We have a value stream, and the value stream is a process, okay, that has a certain set of units, the process steps, the process owners, material flow, and information flow. And all these elements are important. Don't forget them when you explain what a value stream is. And then we have variability. The fourth element is variability. And in this context, there are many ways to describe variability, but in this context, we will take as a first approximation that variability is our standard deviation. Standard deviation of a certain set we will describe later what that is, set of key performance indicators, KPIs. You remember from last semester that we learned how to perform a principal component analysis, right? This principal component analysis was based on the covariance matrix, and this helped us choose relevant KPIs. So make sure you look into this again when you prepare for the sum of this lecture. Okay. Principal component analysis is going to be important. So we have a social technical management, social technical management system that aims to reduce systematically process or value stream variability. Okay. Any questions so far? Any questions? Okay. Now I give you 10 minutes to think about possible technical and social dimensions that we need to take care of in this analysis. To stop the meeting, and before I mean the standard deviation. The standard deviation is a statistical measure. You need to know this. This is the first momentum. First momentum as applied to the mean value of certain KPI. You need to do that. So you have 10 minutes. In 10 minutes, I send you another meeting code to analyze the different dimensions of the technical and social. Please think of these 4 or 5 dimensions of technical and social elements in this context. See you in 10 minutes. So we continue with this point, number 1. Okay. And in this aspect, this 2-dimensional aspect of social technical dimension of such systems. Social technical I asked you to look at different dimensions of this reality. Let me take first the 1.1 social. We start with the individual. At the individual level. Can be you, anybody. Okay. Here we are looking for trust. Trust. This is the main. We're looking for trustworthiness. This is the main dimension that we're looking for in Deutsch, Vertrauenswürdigkeit. Here we are trying to figure out if the individual has a balance between character, who he is or who she is, and competence. What this person can do. Character and competence. This needs to be in balance. Nobody would call a doctor that has a very good character but has a wrong competence. So it is a very nice doctor, but he cannot help me with my illness. Nobody would call a doctor that has not the competence that I need. A doctor, in his role of doctor, in her role as doctor, needs to have both. Next level is the relational level. Relational level. Here, we are looking for trust. Auf Deutsch, Vertrauen. Okay. We can think about trust like we think of a bank system, a bank account. With anybody that we interact, we either invest trust euros, Vertrauenseuros, or we take this trust euros out of the account. Okay, this is like a bank account. Of course, we are looking forward to increase trust. We saw it before here. We want to achieve our goals by increasing trust. Increasing trust. If we don't achieve our goals while increasing trust, then we don't achieve them sustainable or sustainably. This is a matter of time. I cannot go fast with people. If I try to go fast with people, then people will show me that they don't build up trust. So I need to go slow with people. If you want to go fast with people, you need to go start slow with them. Increasing trust takes time. This is important. It is a rule that we take as self-evident that I cannot have trust if I am not trustworthy. So it is impossible to build trust without being trustworthy. This is very important. Next level is the managerial level. Let's take, this is one project member, and this is the hand of the project manager. Example, okay. So managerial management. Here we are trying to empower people. Empowerment, in Deutsch, Befähigung. I cannot empower somebody if I don't have a trust relationship with this person. That's why it's so important that a teacher is, or a manager is trustworthy. Okay. The last level, this is what we will be dealing with in the next couple hours, is alignment. So all these vectors of management take an organizational dimension. Let's say you have one project regarding IT, another project regarding logistics, another regarding whatever, and then they all take place and try to support a certain set of strategic goals. Strategic goals. So here you have the goals. You saw before we try to achieve goals while increasing trust, and this is management. So we try to achieve these strategic goals while increasing trust, and for that we need alignment. Das deutsche Wort für Alignment ist Alignment. Ich meine, ich würde sagen, deutsche Wort für Alignment would be eine gemeinsame Ausrichtung. Okay. So on a social organizational level, we're looking for a common direction. This common direction is given by the strategic goals, by the strategy. That's why it's so important to have a strategy. It is not possible to build alignment. It is not possible to build alignment without empowering people. It's not possible to empower people without creating trust. It's not possible to creating trust without being trustworthy. And I cannot stress this enough. If you are not trustworthy as an individual, you will not be able to be successful in life. At some point, you will have a problem, both personally or at work, or you will just get out of balance. You need to work on yourself, and there is no shortcut. There is no way to withdraw from that responsibility. Any questions? Good. The next level, or the other direction, the other dimension we will be investigating. This was point 1.1, maybe 1.2. Okay. Is the technical dimension. 1.2. It's a technical dimension. And of course, this is just a model that is not explaining the whole reality. Okay, this is only a model. But with this model, we can understand a couple of things better. So now let me model also the technical dimension of such a system in a following way, 4 levels also. So the first level, let me take a factory because you're in industrial management study. Let me take a machine. Okay. This is the shop floor level. This machine, you have a lot of micro technology, microprocesses, all together, very complicated. Artificial intelligence is being in there. I don't know. Okay, so there are a bunch of little processes that are going on within this machine. So this process is going on here. And many of them we don't even understand. Okay? They're super difficult to understand. And so there are processes here that need to be stable, and we need always all these dimensions. We're looking forward to reduce variability. You remember the standard deviation. There are other ways to measure variability, but we don't take them into consideration because they're too complicated right now. Try to reduce variability. So the next level would be what we call a value stream, a doc-to-doc value stream. Okay, although all are processes, but this is called doc-to-doc. So that you visualize it, we just take many of these machines that are put together, creating a certain process. Just you can visualize an assembly line, okay? A doc-to-doc process, which has also, so you see this unit is within this unit. Okay. The next level is to have a factory. Okay. Pretty. To have a factory, and within this factory, you have many of these doc-to-doc levels. Different product lines that are put together so that you get to your customer. And here you have your takt time. The next level, and we will stop there. There are more maybe in between, and this is just not trying to describe the whole reality in all the supply chain. Okay, so you have many factories, very complex supply chains, very interdependent supply chains in which either you have a very good inventory management and logistics and I don't know what. Either you have that or you will be just out of business very fast. So these factories and these processes are within. Okay, so maybe with these colors you can visualize it better. So you have the process within the machine. In violet, these machines are within a process, a bigger process, doc-to-doc process. This is bigger within the factory. This is bigger without the supply chain. Any questions so far? We have these two dimensions. One social, which we're looking for strategic alignment through trust building. And we have a technical dimension based on the systematic reduction of variability. Any questions, please? Questions? Well, if there are no questions, what we have then is The system, if you remember what we painted in the beginning here, socio-technical system. Use the same colors so that it's pretty, and you can find it later on. We have a socio-technical system, social, individual, social, individual, relational, managerial, and organizational. Individual, relational, managerial, and organizational. And you have your 4 technical levels. You have your shop floor, dock to dock. You have your factory, and you have your supply chain. So you have your shop floor with your machine, you have your dock to dock, you have your factory, and you have your supply chain. And the question is, how the fuck we manage all this mess? Because we are dealing with people, and we want to make money with our processes. We are wandering around and trying to figure out what to do here. What do we do? How do we manage all this? That's the question we're dealing with. In order to achieve our goals while increasing trust. Okay? This is the main challenge that we're trying to deal with. Any questions so far? Okay, and we make a little break. In about 10 minutes, I send you another invitation. We continue then with the last concept of this session called cyber physical system. Okay, and this is a conceptualization of these 2 dimensions, social and technical. Just imagine a network of people that have, let's say, wearables on them. This guy is having some glasses that give him information, Google glasses, or he's got an iWatch giving him information, or he's got a phone that sends information all the time. Okay, so these people are constantly generating, and this is important, they're generating information in 2-dimensional tensors. This is time, and this is the information coming from all his devices, position, and so on and so forth. So we have a network of people interacting in factories and other settings in which we are creating value. And they're communicating and they're interchanging information, material, money, whatever. But they're not only interacting between each other. so or with each other. They are interacting also with machines. Okay, let me paint here a computer, but I don't mean a computer, I mean a machine. Okay, some sort of device that has a set of artificial intelligence or a producing machine, as we had before, or a car, I don't know, whatever. Okay, whatever that is not human and can perform some task. Robot. Laser, okay, whatever. All these elements in the network are exchanging information. They're exchanging material. They're exchanging money, cash. Or any other sort of element that is relevant for the customer. What is important is that here, what do we need? We need to understand the network structure. We need to understand the network dynamics so that we can create an organizational goal achievement while increasing trust. And this is the challenge that we have: organizational goal achievement while increasing trust. In order to do that, we are going to try to better create such goal achievement by understanding in the next couple of hours network structures and network dynamics. And this, of course, can be implemented to project management because, as we saw the other day or in the previous lectures, projects are just networks, like any other complex system. Okay. So, any question? Yeah, there's a question. Is network step 2? Is this network step 2 management system? I don't understand the question, Flo. Can you repeat the question? What step 2? Is this network that you draw the step 2? No. This network, this is a cyber physical system. This is the whole system. We are trying to perform lean management on top of this system. Number 2 was about achieving goals while increasing trust within the network. But step 2, yeah, well, step 2 is a system, not the management system. The management system is something that we try to put on top of our network so that we create the conditions that we are trying to generate. Auf Deutsch. Wir haben ein Netzwerk und dieses Netzwerk sollte halt geführt werden. Und wir wollen, dass es geführt wird, damit wir unsere Ziele erreichen bei gleichzeitigem Vertrauensaufbau. Und das schaffen wir durch dieses Netzwerkverständnis der Struktur und der Dynamik. Okay? So kann man es zusammenfassen. Wir wollen unsere Ziele erreichen Nein, es ist nicht bei den 4 Punkten dabei. Wir wollen unsere Ziele erreichen bei gleichzeitigem Vertrauensaufbau. Und dafür wollen wir die Netzwerkstruktur und die Netzwerkdynamik besser verstehen. Okay? Gibt es Fragen? Gut, dann, wenn es keine Fragen sind, sehen wir uns später um 5:30. Ich weiß nicht, wann es genau ist. Also, bis später. Servus. So we continue here. I added a number here, number 5, to answer to the question before. We're talking about a system, and in the beginning we were talking about a management of a system. Okay, so I added a number 5 here. You see, and this number 5 is going to be our cyber physical system. Okay, so this is number 5. I hope this clarifies the question. So now we are going to be talking in the next couple minutes about 5.1. Okay, and this is going to be our network structure, or a little bit about network structures. A little introduction. You already know how to calculate certain KPIs, network structure. You already know how to calculate the clustering coefficient, the average path length, and the grid distribution from previous lectures. And basically what we do now is we try to understand what this means and what applications we can figure out from it. So let me paint a little graph. And let me, this x-axis n, which is n, is the number of nodes in the network, and average path length, APL. Okay. APL is the average length. And let's try to understand what happens when we increase the size of the network with n. Okay, this is the size of the network. How the average path length is going to change depending. So let's say, what is the change of the average path length as a function of the size of the network? Let's say n. Okay, size is n. As a function of the network structure. And this is an interesting question. So depending on how we structure the network, our average path length is going to behave differently. And this is relevant for our purposes later when we design a project or when we design a process. Because if we have a certain set of resources, let's say we have a certain set of nodes, and we cluster them in different ways, we will get different performance. Okay, so let's imagine the first type of organization, project, or in general network, which is a one-dimensional network. Okay, imagine you have just one hierarchy, and your organization and your project is just one long chain of command. Okay, so, and this is just hierarchical, and everybody is giving commands to the top, and commands to the bottom. So it's a top-down organizational design. Okay, we will call this pure hierarchical. Pure hierarchy. Okay, if you can imagine the military. Okay, so the average path length is going to behave like this. It's going to behave like proportional to n. So the bigger your organization, the bigger n grows, the bigger the size, the bigger your average path length, which is not very good because your average path length should be as small as possible, as you already know. Okay, so a one-dimensional, pure hierarchical organization is going to behave bad when growing. Because of this, management theorists and practical managers have thought about another type of organization, which is a matrix organization. Probably you've heard of this. It's not pure hierarchical, but also process-oriented. So here in the horizontal, this is just a generalization. Okay, in the horizontal, you describe the process, and in the vertical, you describe the hierarchy. It's like whereby here you just describe the hierarchy. Pretty okay. So we find no. So here we have the hierarchy, and here we have the process. We have the process, and we have the hierarchy here, and in the middle, node, our cyber physical node, which is just there, and we call this the matrix organization. Matrix. So in our two-dimensional, this is one-dimensional, okay? Let me paint it in a specific color. One-dimensional. And now we have a two-dimensional, and our average path length is going to behave differently. So n to the pointed of so square root, okay, square root of n. This is a two-dimensional. Okay. So this is the two-dimensional type. What happens? What is happening is that now, for a given number of nodes, let's say n0, we have reduced our average path length by all this. So our system has gained this delta in performance because our average path length is shorter. We can transmit information, material, money, whatever, faster from A to B in the network. Okay, this means better performance. The same number of nodes, so you don't pay more people, or you don't pay more computers, or you don't whatever. The same number of nodes, different way of putting them together. As you see, you get your stuff faster to your goal. Okay, so this is why you do it. Any questions? Any questions? The file is going to be sent to you as always. Okay, you don't need to ask that. I always send you the file, the PDF. You have the video, you have the file. But that doesn't mean that you should not be taking notes right now. Okay. So the third dimension takes place when we not only have the hierarchy, okay, you not only have the hierarchy, you not only have the process, but you also need to translate, let's say, one of these processes to another factory. Okay, so imagine you have a factory in one matrix in Stuttgart, and then you have another factory in Ankara. And you want to translate one process of this factory to another process of the other factory because the cost is, so this translation of information, material, whatever in the supply chain needs to be done in a very effective and efficient form. And for that, you need a third dimension in your management system. Okay, so you need another third dimension in your management system. So, and for that, what we're going to do is take another color. Let's see it very well. Okay, so this is a third dimensional, and this, we call this translation of knowledge. Okay, we call this standardization. Or Yokotenkai. Yokotenkai, okay. Yokotenkai. This is a Japanese word for standardization. So you want to translate your information from one place to another, and then you use this extension of the network. And the performance of the network is going to be n to the 1/3 potent. Third dimension. If you continue doing this with 4 dimensions, okay, I don't have more colors, but you imagine I take the green and the yellow, but this paper is not going to be very well. And so you can take one cube. This is the way, for instance, that Google works. And then you can take another cube. This is done in IT project management very often. And then you connect the cubes. Okay. And these are usually just temporal connections that create huge amount of performance increase. But this is only done in a limited amount of time. So the performance increase is again given, and it takes 1 to the 1/4. This is a 4th dimension. And this is just usually just a matter of time that just like a cloud of people working together that get out of the project as soon as the whole thing is over. And this is called virtual project management. This is the increase in performance that you get, delta 1, delta 2, delta 3. And you can go ad infinitum with n dimensions. You can go ad infinitum with n dimensions. In the limit, you can get n dimensions and get that. Okay. So actually, the perfect or the natural way of performance is given by a so-called small world network. And this, we will talk about this in the next lectures. This gets a performance that is similar to logarithms of n. Okay. The human brain, but we cannot get there yet. The human brain works at a so-called scale-free network. Human brain or the internet works at a performance, a scale-free network, and we get here a performance of logarithms of n, which is huge. Okay, this is just huge. Project management is just a lot. Okay, any questions? No questions? Well, then you get an exercise for next week. I want you to give me at least 3 examples of real organizations or projects with 1D, 2D, 3D, 4D, scale-free, small world, and scale-free organizational design. At least 3 examples of each. Okay. And please give me data. Data means you go and do your research and take and tell me the number of people in the network. You give me the network structure, measured in average path length or clustering coefficient, and so on and so forth. Okay, so I need you to back your assumption in data, not just say, well, I think this could be like this. No. Tell me organizations that have 1D, 2D, 3D, 4D, small world, and scale-free organizational design. Also projects, but backed up with data. Okay, the information is in the internet. You can access it and you can look for it. Any questions? Well, you can access this video here as usual. I ask you again for feedback on the YouTube channel, because not for me, but for the community doing e-learning. I thank those that have already done it. Please do it again. As I said, it's important that in these times we maximize the amount of information so that people see that it works, and so that people see what doesn't work, so that I can do it better. Okay? Good. So, well, thank you very much for your time. And if you have any questions, you just come back to me. If you have the solution and you want to check out if the solution is correct or if something is missing, just email me or send me a WhatsApp notice, whatever. And stay safe and stay at home. Bye-bye.